Hey everyone, this is a video on polar coordinates and equations, and we're going to look at probably this in two videos. We'll go over the polar coordinates first, and then we'll talk about converting the equations in another one. So just to start off, polar coordinates are basically just a different way of naming and plotting points. So I have kind of the equivalent rectangular or Cartesian system, as it's sometimes called, with the usual x and y. So even if you're not familiar with the name, you're probably used to graphing in this scenario where x is just how far over you're going to go, y is how far up you're going to go, and you just plot points with x and y, that sort of thing. The polar coordinate system is going to have, again, two things, right? So instead of x and y, polar is going to have r and theta. So everything's going to be graphed with r and theta. And so I've drawn an equivalent triangle in both of these coordinate systems. So you'll notice on here that this theta right here is the same as the theta right here. The x along, right, going across, right, is the same as this x going across. So everything on those is kind of the same, right, for those guys. Y goes up, r is what we would call, say, the radius of a circle, right, but it's also just the distance from the center, right, that 0, 0, what we usually call 0, 0, all the way up to that point. And we'll talk about the names of points as we go along, but 0, 0 is the rectangular name. We'll see a little bit later what that would be in polar. So let's go ahead and kind of talk about a few things. Equivalencies, right? So these are some of the formulas that we'll use, and we'll talk about that in terms of those triangles up above. The first one is just r and theta, right? Changing from polar to polar. What does that mean? So I'm going to go ahead and leave that part there. So r and theta, r is just how far out you're going to go from what we call the pole. So this center point right here, that is what we call the pole. And how far out you go, right, out to this point, that was a terrible line. We're going to retry that. So how far out you go, right, all the way out to here, that is just going to be my r, right, whatever distance that is. So if I were to draw a point, say right here, and go out that distance, right, that is my r, how far out that went. So r's generally are going to be positive. You can also have negative r's. We'll talk about that in a second. The theta is the usual theta that you would get like moving around the unit circle. So theta is going to be starting on what we would normally call this positive x-axis. This is actually the 0 axis right here. So that is the 0 axis along what we would normally call positive x. And then as you move right counterclockwise, you're just going to make that angle of theta. So if I were to put, say, this coordinate here, whatever that theta is, it's not really well defined, right? Whatever that theta is, that would be what I would put in that second coordinate for the theta. And however far I moved out, that would be what I put in for my r. So if I wanted, let's say, change colors here. Let's say I have a point right here, right? I could say, all right, well, my theta is going around, right, this way to the 11 pi over 6. And I'm going to go out, and I would just count the units, right, out to that point. So we would count out 1, 2, 3, 4, 5, and I would call that point 5 for my r, 11 pi over 6 for my theta, and that's it. Right, so 5 comma 11 pi over 6. Now there are several different names that you could use, right? So for the same point, so this same point, right, that's right here, let's say instead of doing a positive angle, I did a negative angle, right? So I just went this way with my negative angle. That is going to be negative pi over 6, right, to get here. and I still go 5 units out. So another name for that is going to be 5, comma, negative pi over 6. So that is something that is different than the rectangular coordinate system with x and y. There's always a unique name for every point, right? So every point, if I say, where is this point? This would be at 6, 5. There is no other name for that point, right? It's definitely just the point 6, 5. 6 is x, y is 5. That's the only name for it. In polar, that's not the case. So in polar, you're going to have all kinds of different names for the exact same point. So when we get to graphing polar equations, you'll see graphs can overlap, they can cross each other, just because the names for certain places in this plane are not unique. All right, I'm going to go ahead and erase all that stuff, and we'll talk about negative r's next. So negative r's, this is going to be something where if I have, let's say, I want to graph, what do I want to graph? I want to graph this point. Let's say we'll use 5 again. 5, comma, 5 pi over 6. So that's the point I want to graph. Actually, negative r's is what we'll do. So, so positive pi over 6 for the angle. I'm going to erase that. And negative for the r. So negative 5. And then 5 pi over 6 for the angle. All right. So we know where that angle is, right? 5 pi over 6. That's right there. But instead of going along the line toward that angle, right, or along that angle, negative r's are going to go the exact opposite way. So we would start here, and instead of traveling along this line right here toward that 5 pi over 6, we're going to go the opposite way. So 1, 2, 3, 4, 5. That's where I would put my point right there. So we're just moving along that negative opposite direction, right? So negative usually goes right opposite of where you would normally go if it was positive. Same deal in polar coordinates. We're just going to go in the opposite direction of that 5 pi over 6. So that's what we're looking at. So that's where that coordinate would go right there. So a couple formulas that are nice to know. R theta is equivalent to the same r and adding any 2 pi k to your angle, right? So I can add or subtract 2 pi. We're assuming k's can be negative there. So I could subtract 2 pi again as many times as I want, and I would get an equivalent coordinate for that r and theta. If I had an r and theta and I want to make r negative, then I can just add pi, right? Because pi is going to go halfway around. So if I took a 5 pi over 6, added pi, that would take me to 11 pi over 6, and I could call the same coordinate, right, positive 5 and 11 pi over 6. Or if I wanted to subtract pi, I could also do that, have another equivalent name for that point. So, so that's going to be the weird thing when you first get started with polar coordinates is places in the plane have several names that you can use. Let's go and do just a couple more, and then we'll talk about these formulas over here. So if I wanted to say, look at the coordinate for point A, again, there's several names that you could do for this one, but one of them is 1, 2, 3, 4, right? So we're moving 4 out in the R, and then this is along the line pi over 3, so 4 comma pi over 3, that would be my coordinate. If you wanted to get a different name, right, you could add 2 pi to this angle, keep the 4. I could say this is opposite, right, the 4 pi over 3. That's right here, so that's an opposite angle. So I could say this is negative 4 with the 4 pi over 3. That would be another name for that point A. Very often, because of this issue, when they're asking for you to change things to polar coordinates or give a polar coordinate, they will often say give the r as positive, give the theta as between 0 and 2 pi. So a lot of times they'll kind of make that restriction just to kind of narrow things down a bit. But in general, polar coordinates have lots of different names, and you can always use kind of these things if you ever want to change from one polar name to another polar name. The other thing here is that we're going to change between polar and rectangular. So if I go up, I would like to know, right, if I'm given this 0.65 in rectangular, right, that's right there, what would that be in polar, right? So what would the name of that point be in polar? And some of these formulas down here are going to help us. So just generally looking at these triangles first, let's see what we get. So this is a right triangle, right? So this is a right angle right there, right angle right there. And as such, we can use all of our trig with right angles that we've covered before. So things like the sine of theta is y over r, right? Opposite over hypotenuse. Cosine of theta is x over r, that adjacent over hypotenuse. Tangent is opposite over adjacent, so y over x. And Pythagorean theorem, right, also works with right triangles. So x squared plus y squared is r squared. So all of those are kind of listed down here. You'll notice the sine theta being y over r, they've kind of changed that to y is r sine theta, just moving the r to the other side. Same with that cosine being x over r, they've just moved that r to the other side. So these formulas are going to be extremely useful as you're converting coordinates, and we'll go through that probably in the next video, just how to change from polar to rectangular and rectangular back to polar. So I'll see you on the next one.